take a look at this problem. We want to factor this completely if possible. If not possible, write not factorable. So we've got 25 x squared plus 40xy plus 16y squared. Now, if you spot some items about this, there's a short way to do this. Notice that this right here, the 25 is 5 times 5, and the x squared is x times x. So this would be 5x to the second power. Now, our last term here, 4 times 4 is 16, y times y is y squared. So this would be 4y to the second power. If you see this pattern, then that potentially would trigger that you need to use this method. This is perfect square trinomial method. Now, in order for this to work, though, this middle part here has to be 2 times what's inside the parentheses here times what's inside the parentheses here. So let's see if that's true. Well, 5 times 4 is 20, times 2 is 40. And we got 40xy, so that works. Now there's a formula for this, and it all depends on what kind of variables you have. I use, I guess, a's and b's. If you got a squared plus 2ab plus b squared. Now a and b do not have to be a single letter or a single anything. They can represent a term like 5x or a term like 5y. So in this case, the 5x would be my a, and the 4y would be my b. And notice this is 2 times a times b. Then our formula says, if you got it exactly like this, then you can rewrite this as a plus b squared. Okay. Well, then this becomes a, which is 5x, plus b, which is 4y squared. And that's our answer. Now let me show this with another method. If you see that, that's great, but these appear so seldom in algebra that a lot of people never recognize them when they see them. And if we go to our methods for factoring, the main methods we have, we have our first method, which is GCF, and that's the greatest common factor. We have our second method, which is grouping. And this was when you have 4 or more terms. We have our third method, which is PST, which is the form x squared plus bx plus c. Then we have the key number, which is of the form ax squared plus bx plus c. There's dots, difference of 2 squares. This is when you got 2 terms with a minus between them. Then we got the difference of 2 cubes. And this is when you got 2 terms with a minus between them. And then you got the sum of 2 cubes, which is 2 terms with a plus between them. Okay, we start going down through our methods. GCF, they don't have anything in common. Groupings 4 more terms. Well, this is 3 terms. That doesn't fit. PST is close, except for you can't have anything in front of your x squared. Now you're saying, well, there's an x squared, but there's also y's. Well, remember our pattern is x squared, x, no x. You can have additional variables. This is key number. X squared, x, no x, number in front of your x squared. So x squared, x, no x, number in front of x squared. So key number now remember the key number, you take the number at the beginning times the number at the end, ignoring signs. So we've got 25 times 16, which I think is 400, but I'm probably wrong since I'm kind of sleepy. Let's see, 25 times 16, 400. And we're going to come up with our 3 columns. P column, S column, D column. P column is all products give us 400. We got 1 times 400, 2 times 200, 4 times 100, 5 times 80, 6, no, 7, no, 8 times 50, 9, 9, no, 10 times 40. Usually I do pretty good up to 10, but 11, I don't think so. 12, once you get to a certain point, you could use a calculator. So if I do 400, that way I don't think so. I have to think so hard this morning. 400 divided by 12, we get decimals, doesn't divide into it evenly. 400 divided by 13, I'm pretty sure that doesn't go into it, but just to show it. 400 divided by 14. Enter. Still nothing. 400 divided by 15. That's a possibility. Nope. 400 divided by 16. Oh, yeah. 16 times 25. Yeah, I always have trouble with the one that's right up here. So 400 divided by 17. Nope. 400, there's actually one more. I don't think there's any more than one more. 400 divided by 18. 400 divided by 19. And here's the one I actually can see. 400 divided by 20. Notice it's 20 times 20. Okay, the S column, we want to add these together. 1 plus 400 is 401. 2 plus 200 is 202. 4 plus 100 is 104. 5 plus 80 is 85. 8 plus 50 is 58. 10 plus 40 is 50. 16 plus 25 is 41. 20 plus 20 is 40. Difference column, subtract smaller from larger. 400 minus 1 is 399. 200 minus 2 is 198. 100 minus 4 is 96. 80 minus 5 is 75. 50 minus 8 is 42. 40 minus 10 is 30. 25 minus 16 is 9. 20 minus 20 is 0. Now, a number we're looking for is a number in a middle term, which is 40, which is right here. So we're going to use 20 and 20. Now we're going to rewrite our middle term using those two numbers. Typically our larger number that we're using in the P column, now notice these are both 20s, so there's no larger number, so we'll just pick a 20. But our larger number is always the same sign as the middle term. In this case the middle term is positive, so we're going to have a plus 20xy. Number I circled in the S column, S for same signs, both positive, both negative. Since that one 20 is positive, the other 20 will be positive. And then we want to factor by grouping. So group first two terms together, group last two terms together. First two terms have a GCF of 5 and an x, and that gives us 5x plus 4y. Now second group, let's see, has a 4 and a y as GCF, and that gives us 5x plus 4y. Our goal with grouping is to get this parentheses the same as this, so I can factor out the 5x plus 4y out in front. And to decide what goes in your second set of parentheses, you come up here and you cross out these 5x plus 4y's, and what isn't crossed out is what goes right here, which would be 5x plus 4y. And since we have 5x plus 4y times 5x plus 4y, we can rewrite that as 5x plus 4y squared. And that'd be our answer. So you can see that you can use the key number to find this particular type of perfect square trinomial. There's another formula for the perfect square trinomial method. And again, if these appeared a little bit, you see these a little bit more in algebra, then it'd be worthwhile to really spend time. But a lot of students never get perfect square trinomial, which is no big deal. You have to work a little bit harder on the key number, but you get the same answer.